This experiment is all about the synthesis of acetyl salicylic acid, more commonly known as ASA. And this chemical is one that's used as a painkiller, and it's the active ingredient in aspirin. The goals for this experiment are to review and practice some of the techniques that you learned in a previous lab course, and to experience the synthesis of an organic compound. In previous experiments, we've synthesized a chemical, that is, we've made a chemical from some reactants. But this is the first time where the goal of the experiment is to produce something new. In this experiment, we'll be using a number of different chemical reagents. And now that you have WHMIS safety training, you need to be looking up the safety data sheets for all of these chemicals and assessing the hazards associated with the chemicals. There's only one chemical with a specific safety hazard that we're going to point out in this video, and that chemical is acetic anhydride. At one point in this experiment, during the workup, you'll be asked to add water to some leftover acetic anhydride. When you mix water with acetic anhydride, you will form acetic acid. And the reaction is extremely exothermic. It gives off a lot of heat. And because of this, when you decompose the excess acetic anhydride, you want to do so in a fume hood because there's a possibility that the heat released will cause the mixture to splash out of the test tube. And that puts you at risk of being splashed with an extremely corrosive material. The procedure for this experiment can be broken into three general categories: a reagent mixing category, an accelerating the reaction category, and finally a reaction workup. At the start of the mixing step, you'll be given a test tube that contains 3.5 grams of salicylic acid. You're going to add 5.0 milliliters of acetic anhydride into that test tube using a tipping dispenser. As most of you have not used a tipping dispenser before, here's a clip that will show you how to use one. This is a tipping dispenser. It's a piece of glassware designed to dispense a set volume. This one dispenses 5.0 milliliters. It consists of an outer chamber and an inner chamber with a notch cut into it. You can tilt the dispenser so that solution fills the outer chamber, and if you tilt it far enough, the solution will start to pour into the inner chamber through the notch. The solution can't fill past the opening in the inner chamber, and once it's filled to the maximum amount possible, that amount is calibrated, in this case to 5.0 milliliters. You then tilt the dispenser in the other direction to dispense the solution. Once you've added the acetic anhydride, you'll have a test tube containing both salicylic acid and acetic anhydride. To this mixture, you need to add 3 drops of concentrated sulfuric acid catalyst, and you can do that using a dropper bottle. You'll then need to mix the reactants thoroughly with a thermometer. Once you've finished the mixing step, you can move on to accelerating the reaction, and we'll accelerate it using heat. So you need to set up a hot water bath by placing a piece of wire mesh onto a tripod and setting that up over a Bunsen burner. Then you can take a large beaker and fill it about 3/4 full with water and heat it up to about 50 or 60 degrees Celsius. And you can determine the temperature with the thermometer that you left inside the test tube. Continue to stir the mixture with a thermometer until all of the solid dissolves, and then continue heating at that temperature range for an additional 10 to 15 minutes. After you're done the heating process, turn off the heat, remove the test tube from the bath, and allow the mixture to cool while stirring occasionally. At this point, a solid should start to precipitate. After cooling, we can move to the reaction workup phase of the experiment. Bring your test tube to a fume hood and add 10 milliliters of distilled water to the tube and stir well with your thermometer. After this, take the tube back to your lab bench and transfer the mixture into a 250 ml beaker using 4 10 ml aliquots of water to do the transfers. Then stir the contents of the beaker well using a glass rod and suction filter the material in order to obtain your crude acetylsalicylic acid. And once you're done filtering, continue to draw air through the filter in order to dry your solid as much as possible. And at that point, you want to transfer your ASA onto a watch glass and weigh it. After obtaining your crude ASA mass, you can calculate the percentage yield of ASA. To do this, you take your crude mass of ASA and divide it by the theoretical mass of ASA, and multiply by 100. You should be able to find your theoretical mass of ASA based on work that you've done in the PreLab assignment.